Hi everybody, this is Miss Motzi coming at you from room 168. I wanted to talk to you today about station models. I'm really sorry I couldn't be at school today. I'm off-site doing some training, but I really wanted to make sure that you got to know about station models and that you do the practice, because we are having a quiz on this next class when I see you on Thursday, January 24th. First, let's take a look at where we are in the unit. You've come a long way since the beginning of the weather and climate unit. We started this unit for you all on January 8th. We started out looking at weather tools like anemometers and barometers, and then we looked at isotherms on maps. On day 2, we looked at isobars on maps, and we also looked at low pressure lousy weather, high pressure happy weather. On the next day, on day 3, we looked at air masses like continental, tropical, and maritime polar, and we looked at cold fronts and warm fronts. On day 4, we looked at precipitation along fronts, and I think we need to review that. And then day 5, we looked at severe weather. You had some choices, so you were looking at blizzards, hurricanes, and tornadoes. Now it's today, day 6. You're going to learn about station models. When I come back on Thursday, you're going to be forecasting weather yourself. And then we'll have a day of climate when we look at the different climate zones and how to create a climate graph. Then the unit will come to an end. You'll take your unit test, and B-Day's unit test right now is scheduled for January 31st, so you can keep that in mind. That's if we don't have any more snow days. All right, so let's get to what we're talking about today. How is it that meteorologists are presenting or representing weather on a map? They have a lot of different variables that they need to represent. Things like temperature, dew point, air pressure, sky conditions, wind speed, wind direction, whether or not the barometric pressure is rising or falling, what the precipitation is, and what the precipitation amount is. So how they represent it is what's called a station model, and it all starts with a circle. So you have a circle here right in the middle, and then what you have next is temperature. So temperature is represented in the top left-hand side of the circle. Now, cloud cover is how many clouds are covering the blue sky. So that's represented by darkness inside the circle. So this represents approximately 75% of the sky being covered by clouds. So if it's white, that means that you can see the blue sky. If it's dark, that means clouds. Then we have this sort of staff here that represents both wind direction and wind speed. So the wind direction is what direction it is on the circle. So this wind direction here means that the wind is coming from the southwest side. Then these barbs over here, they indicate the wind speed. So if we were to take a closer look at that here, you see that the whole feather, a feather is this long line coming off of the stem, is 10 knots, and a half a feather is 5 knots. So this one has a 15 knot speed. Now this one has 10, the one on the left has 10, 20, and a half a one, so that's 5. And it's coming from a northeast direction. This wind here looks like it's coming from the east, and it looks like it only has half of a little feather. So that looks like an east wind at 5 knots. And then this one here is coming from the southeast. Remember, west and east spell we. The west is on the left-hand side, east is on the right-hand side. That looks like a southeasterly wind at 10 knots. All right, back to the station model. So we have temperature, amount of cloud cover inside the circle, and then the wind direction and the wind speed. Now, visibility is something else that is represented on the station model. That means if it says 1/2, that means there's a half a mile visibility. So it could be that there's fog or snow. Oh, here we go, present weather. So that star right there indicates snow. Let's take a look at the different symbols for precipitation. You can also find these in your textbook. On page, this looks like page 457. So it's in chapter 20, and you can look at all of the different symbols that you need for a station model. In chapter 20, let me see what section it is. Section 5. So 20.5 in your textbook also has a lot of information about these different station models. Let's get back to our actual PowerPoint. All right. Present weather symbols. Some common ones are just the dot, that's rain. This is a common one here for thunderstorms. It's like this zigzag line with an arrow. Another common one is haze. That looks like an infinity symbol or an 8 that's been put on its side. And here's one for fog. It looks like an equal sign. For snow, it's like an asterisk or a star. That's what's representing snow. And sometimes they'll put like 1 star means light snow, 2 stars means moderate snow, and 3 stars means really heavy snow. So you can keep an eye out for that as well as you go through the different exercises. All right, so we have temperature, cloud cover, wind direction, wind speed, present weather of snow, and the visibility is low at 1/2 mile. Next up, we have barometric pressure. This is where it gets real. You have to pay attention because barometric pressure gets decoded and encoded depending on whether or not you're putting it onto the station model or you're trying to get the barometric pressure off the station model. So let's take a look at how this works. All right, here we are with the barometric pressure. Decoding the pressure. Say that the station model has a pressure of 196. We need to be able to decode that. So to do that, you're going to insert a decimal point to the left of the last digit. That means you would insert a decimal point between the 9 and the 6. All right. Next up, you're going to put a 9 and a 10 in front of the result. So now you have 919.6 and you have 1019.6. Test the results against the range of normal atmospheric pressure. So you have to use a little bit of common sense here. The normal range of atmospheric pressures is starting down here at 968. That's a pretty low pressure, and going all the way up to 1040. So you're trying to think which one makes sense. In this case, 919 is way too low. That's off this range of normal pressures. So you can assume that 196 on a station model is being decoded to 1019.6. Again, 919.6 is way below the normal range. Rejected. 1019.6 is within the range. Accepted. So your coded pressure from the station model was 196, but the actual air pressure that you're going to know that it is 1019.6 millibars. Let's do a little practice. Decode these coded pressures. So on this one here, you have 002. You're going to have to put a decimal point between the 0 and the 2. And then you're going to put either a 9 in front of it or a 10 in front of it. So you'll have 900.2 rejected, too low. Or you're going to have 1000.2 millibars. Yeah, that would be right. All right, let's take a look at this next one. You're going to put a decimal point between the 9 and the 3. Now you have to put a 9 in front of it or a 10 in front of it. 999.3, that could be, because that puts you in the normal range of air pressure. Or 1099.3. Oh gosh, no, that's way too high. That's off the normal range. So the answer would be 999.3. All right, so far so good. Let's look at the third example. 280. You're going to have 28.0. So you'll have 928.0 and 1028. 928 is too low. So the correct answer would be 1028.0 millibars. All right, let's look at this final test here. 000. What a weird thing to have encoded in the station model. So it's going to be 00.0. You'll either have 900.0, which is too low, or 1000.0 millibars. 1000.0 would be correct. All right, what if you need to actually encode the pressure. So we decoded them. We took a station model, we saw the number, and we decoded it to regular air pressure. But what if you have the air pressure and then you need to encode it? What do you do? First, remove the decimal point. So you now went from 1013.5 to 10135. Next up, report the last 3 digits. So in this case, the last 3 digits are 135. Simple. That's your encoded pressure. That's a little bit easier than the decoding. Let's see. We have a couple of examples here. So the first one says 1032.7. Take the decimal point out, take the last 3 numbers. That's going to be 327. Good job. The next one, 987.3. Take the decimal point out, take the last 3 numbers. That's going to be 873. You guessed it. Next, you have 1012.2. Take the decimal point out, take the last 3 numbers. What is it that you have? Yeah, you're right. 122. All right, and then finally, last example is 1000.1. Take the decimal point out, take the last 3 numbers on the right-hand side. What do you have? You're correct, 001. Good job. Let's go back and look at the station model. All right, we have temperature in the upper right-hand corner. We have cloud cover in the center of the circle. We have wind direction and wind speed off of this little stem and feathers here. We have visibility. We have present weather or precipitation. We have barometric pressure on the upper right-hand side. And by the way, it really matters where these go. So it really matters that the temperature is in the upper left-hand corner and the barometric pressure or air pressure is in the upper right-hand corner. That makes a big difference. Let's look at our next variable. Barometric trend. This one you'll see sometimes, but you won't see it all the time. This is saying that the air pressure is trending up. All right, next up we have precipitations. Precipitation. You would get this from the rain gauge. So this is 0.25 inches, and that's in the last 2 hours. Sorry, last 6 hours. And then finally, dew point goes in the lower left-hand corner. All right, and then that is it for your weather station model. So next up, you can do a little bit of practice on your own online. So there's some examples here that you can use, and they're asking you, what is the temperature? What is the wind direction? What is the cloud cover? And you can check yourself. If you're wrong, it'll tell you that you're wrong, and you can try until you get that correct. After that, what you want to finish is this station model lab. So this is what the substitute passed out to you. And again, it explains what I just said in the notes. It gives you all the different variables that are listed on the station model. Make sure that you read through the directions and then you answer the questions. It takes you through station 1 through station 5 of all the different variables. You do it again here, you're doing it reverse. You're building the station models and then you're concluding things and looking at a map. Look at this crazy map. You probably don't even understand it right now, but by the end of this lesson, you will. And one thing you do understand about this map is you see this warm front right here on the right-hand side. You see the cold front here, and you're starting to recognize this as a low pressure system that's rotating counterclockwise. So you're going to start to be able to anticipate what sorts of weather you're going to have on either side of those fronts. All right, if you've watched the video this long, you've done a great job. I'm definitely missing you. This is one of my favorite lessons, and I wish I was here to teach it to you, but this is the second best thing I can do is make you a video. Use your time wisely. Make sure that you're learning. You came all the way to school, so make sure that you do a good job on this. If you have any questions, help each other. Ask the substitute. They might know. And otherwise, you can email me if you have any pressing problems, and I will see you on Thursday when you have your quiz. All right, bye-bye. Miss Matzi.